Okay, so everything that we've been talking about so far has been in the short run. We've mentioned a little bit about long run, but we didn't really model anything from it. Now it's the time to do that. So modeling the long run is really just about giving us a new way of looking at the ATC. So we now have a long run ATC, which is just representative of the different levels of fixed inputs that you can have. You'll recall that in the long run, everything can change. So your variable inputs can change, of course, because they could in the short run. Fixed inputs can't change in the short run. So what the long run does is it shows you the different levels of fixed input that change and where your production levels fall upon that. So the way to look at it is each of these curves inside the bigger curve are representative of different short run costs. So this big overarching loop, the one that I'm currently outlining, that's the long run ATC. It's an approximation of all of the short run loops. Here we have one short run loop labeled ATC3. Here we have a second short run loop labeled ATC6. And here we have a third short run loop labeled ATC9. So anytime you see a long run ATC, it's just going to look like a big one with a bunch of short ones in between. So what these are representative of are different plant sizes, or that's the normal setup, different factory sizes, if you will. So if you're looking at it, you might think that ATC3 would be sort of the smallest factory. It would be able to handle the least amount of production. So it might be good for certain levels, but not so good for others. The middle one, slightly bigger. The ATC9, that would be the biggest level represented here. Now, does it always have to be factory or plant sizes? Can it be another fixed cost? Absolutely, it can be. But in most cases, when you're given questions, it's going to relate to factory or plant size. But if you come across any other that switches it up, it's the same analysis. It's just a different fixed cost that it's showing you changes in. So the way to think about this and to analyze which curve you should find yourself on is that you're going to find yourself on one of the short-term curves at any point. So let's say we have a quantity right here at Q1. We might find ourselves on ATC3. We might find ourselves there. Or we might find ourselves on ATC6. That quantity can be produced by either of those curves. Now, if you're thinking which one is better, well, it has to do with which one can produce it at the lower cost. So at that quantity, ATC3 has a lower cost than ATC6. If you wanted to produce here at Q2, then ATC6 would be better, even though, I mean, if you can imagine these two curves going out a little bit further, even though both ATC3 and ATC9 will eventually hit that, they hit it at a much higher cost. So you'd rather stay at ATC6. If you go to this one, let's call it Q3, you'd rather be on ATC9, even though ATC6 can also produce it. So let's say that you were on ATC6 and your quantity was at 3. And you might be thinking, well, if I think I'm going to be producing at this quantity for a long term, then I need to change my factory size. And you're going to switch to the larger factory under ATC9 so that you can produce at a lower cost. By the same token, if you're on ATC6 and you find yourself having to produce less, having to produce a a lower quantity at Q1. Um, if you were on ATC 6 and you have to produce a Q1 and you think that's going to stay for a long time, well, then you're going to want to downgrade your factory size to ATC 3 just to keep it at a lower cost. So that's how you make decisions using the long run ATC. And as I said, it's all about minimizing that that cost for the new quantity. And that's a long-term choice because the long run average total cost curve, the LRATC, is just that relationship when you're trying to minimize the ATC for every level of output. So there's almost an unlimited amount of factories that you could have along this curve, and they would all run tangent to the LRATC. That's kind of what you have to imagine. Now, at any time, you're going to just see a couple, usually like 3 to 5, for ease of viewing's sake. Now, there's a couple of other things to put along with this LRATC. First, it has to do with economies of scale. So economies of scale exists when you are on the downward sloping portion of your LRATC. So when you're here, the part that I'm outlining, the downward sloping part of your LRATC. That is what's known as economies of scale. So you can say up to this quantity, which is why it's sectioned off at the top of this graph. Up until that quantity, you're experiencing economies of scale, which just means that output is increasing at a faster rate than your production costs. That's all it means. Sometimes you'll see this applied to a short run ATC as well. So if output is increasing at a faster rate than production costs, then your ATC, your LRATC, will fall. And this makes sense if you just think about the equation for ATC. The equation for ATC is the addition of all of your total costs. So you keep adding total costs, and you divide it by the quantity. So if your output is increasing at a faster rate than your production costs are your numerator, then your number should fall. This is caused by specialization in most cases. The initial drop off here is high setup cost. So this initial high drop off, that's high setup costs. And as you expand more and more and more, you can buy things in bulk and it gets cheaper and cheaper as you go. That's the idea of economies of scale. For diseconomies of scale, that's the other portion. That's the upward sloping portion of your LRATC. And once again, sometimes you'll see it applied to the same concept applied to your short run ATC. This is when you're no longer benefiting from expansion in terms of keeping your costs low. It still might be profitable for you to be in the diseconomies of scale portion of your LRATC. It still might be profitable and preferable to do that. But in terms of your costs, they will be rising. And that's because now output is increasing at a slower rate than production costs. Once again, think back to the equation for ATC. It's your total cost divided by quantity. So if your total cost is rising faster than your quantity, your end number is going to rise. So that's what's happening here. And this is caused usually by issues with coordination and communication. If you think about having a very, very, very large business that's all over the world, well, then you have to communicate. You have to figure out ways to quickly talk to each other. Something that people are especially having to figure out in today's world of telecommunication. But those costs are now falling. So it is possible to, flatten out your LRATC a bit as you have newer technology that makes it easier to communicate and coordinate. But there are still issues. For instance, if you are not in the same building with somebody and you want to ask them a question, well, you have to now call them. If they're not available, then you have to schedule a meeting with them. And that all slows things down. It might be small at first, but it adds up eventually. Now, there's one more part to go along with this, and it has to do with uh, almost just a change of the wording in terms of economies of scale and diseconomies of scale. And it's really the same concepts. So what you have are what is termed as increasing returns to scale, constant returns to scale, and decreasing returns to scale. So if we're thinking increasing returns to scale, it is the downward sloping part of the LRATC again. Um, so if you mark it off here, it's really about until a quantity of 5 on this graph is increasing returns to scale. It's the same idea as economies of scale, just different terminology. Your LRATC is declining as your output increases. And that's because you are getting more back as you scale up production. That's the difference in terminology about returns to scale. Scale is about your scale of production, how large your production is, your production possibilities for this firm. So with increasing returns to scale, you're seeing benefits. Once again, same exact idea as economies of scale. Now for returns to scale, we do have a constant returns to scale, which is exactly what it sounds like. As you change your output levels, you no longer are seeing a benefit in terms of reducing costs. So it's constant returns to scale. It's a flat portion of your ATC. Lastly, you have decreasing returns to scale. And that is, once again, the same exact idea as diseconomies of scale. So here you have your LRATC increasing as your output increases. So as you increase your scale of production, you now have decreasing returns as average costs will rise. And that's all we have to cover when it comes to the long run average total cost curve.